Today we're going to talk about physical and chemical properties and why they are important. All substances have properties that we can use to identify them. As you guys are going through the slides and watching the video, what I'd like for you guys to do is go ahead and take some notes in your ISN. Specifically, the terms, make sure that you write those definitions because you're going to need to know them. Also, provide examples. As you are done with those notes in class on Monday, you will have time to complete the activities that are already on the slides themselves. We're going to start off with physical properties. A physical property is a characteristic that one can observe or measure without changing the sample's composition. Examples of physical properties could be color, smell, freezing point, boiling point, melting point, infrared spectrum, attraction or repulsion to magnets, opacity, viscosity, and density. Just to get a clear idea of how physical properties work, let's take a look at three substances that you should be familiar with. One of them is sugar. Okay, remember that a physical property could be something like color. We know that it's white in color. We can also talk about odor. It smells sweet. We can even go as far as talking about texture. And texture could be that it's crystallized or granular. And all those would describe it. And they would fall under the realm of physical properties. Baking soda, same thing. We can say that it's white in color, has a soft powdery texture, and that it's odorless. For water, we could say it's clear. We could say that it's a liquid, and we can also say that it's odorless. So those are all examples of how we can identify certain substances by their physical properties. And just a quick reminder that because we are doing physical properties, there will be some math involved. It could either be calculations, and that would also include having to express numbers with the correct number of significant figures. Okay, we're going to start off with talking about extensive properties. Extensive properties do depend on the amount of matter. So think of it as that extensive properties are affected by how much you have. So mass is a property that is affected by the size of an item. Weight is affected by the size of an item. Volume is affected by the size of an item, and as is length. So if I take a look at these copper pots and pans, they're obviously going to have a different mass, a different weight, a different volume, a different length. And once again, that's because they're of different sizes. On the other hand, we have something called intensive properties. Those type of properties do not, I repeat, do not depend on the amount of matter present. And some examples would be color. So if you take a look at these two lemons in a picture, well, it doesn't matter that one is significantly larger than the other, they're still yellow. So the color does not depend on the size. But now, if I asked you to use the extensive property of mass, then size would affect the mass because they would obviously weigh differently. Okay, odor is another thing. And I mean, still using the examples with the lemons, they're still going to smell, they're going to have that citric scent. And again, despite the size, that's not going to affect that. Water, on the for this example, I could tell you that if we have different amounts of water, yes, that would affect the mass, the weight, the volume, the length. So the fact that there's different amounts, but Now, the different amounts won't affect at what point they start boiling or at what point they start freezing. Despite the fact that I have 2 liters and 1 liter, they're still gonna both boil at 100 degrees Celsius. They're still gonna both freeze at 0 degrees Celsius. And once again, size will not affect that factor. Okay, for your assignment, which you'll be doing in class, you're going to be asked to create a T-chart. On that T-chart, which you're going to place into your ISN, you're going to go ahead and write all these properties that are listed, A through N. Right next to it, you're going to go ahead and identify it as being either intensive or extensive. Keep in mind that when you're doing this, make sure that you're paying attention to what it's telling you, as well as ask yourself, is this or is size affecting this? So then you can easily answer that question, and then again write down if it's intensive or extensive. Okay, we're also going to talk about another physical property that's called density. Okay, density is a relationship between mass and volume. Mass we express in units of grams, and volume we can either express in units of milliliters, or we can also express it in centimeters cubed, and I'll tell you how we get those two. But there's 2 ways that we can find out the volume of an object. It just depends on what the object is. Now, if we have a nice cube like this that has sides to it, we can go ahead and measure its length, its width, and its height. So by multiplying those 3 values, that would give us the volume of this cube, or how much space it occupies. But the question is, how do you solve or find the volume for an irregular shaped object such as a rock? And that's where the water displacement method comes along. Many years ago, there was a Greek mathematician by the name of Archimedes. And the story behind Archimedes is that the king had asked him to find if the crown he had made was actually gold or not. So Archimedes had to think about it. He didn't quite know what to do because there was a lot of people that would make fake things. So he knew that he can weigh the the crown, and he figured that different substances or elements have different properties, and he knew that gold had a set density. So he figured, I can find if it's gold or not if I knew the density. But then he thought to himself, how can I measure the volume of this crown if I don't have a set length, width, and height? So he was taking a bath one day, as you can see in this picture, and as he stepped into the bath, he noticed that the water rose. And he thought, every time I step into the bath, the water rises. And what it is that he had the idea that through water displacement, or how much water was rising up, that would be the same amount of volume that his body was occupying. And so he figured, my body is an irregular shaped object, as is the crown, so now I can find the volume of the crown if I were to see how much water is displaced. So they say that he ran into the towel naked, yelling Eureka, because he had figured this out. Okay, so in this picture right here, in this illustration, that's exactly what is being done. You're trying to find the volume of the rock, which is an irregular shaped object, by seeing how much water is displaced. You start with a set amount. In this case, they're using 30 milliliters. I mean, they could have used any amount, but that's where they started. And so as they placed the rock into the graduated cylinder, they noticed that the water rises. In this case, it rose to 40 milliliters. So if you look at the difference of how much water rises, it's going to be 40 minus 30, so that gives you a difference of 10. So the rock is 10 milliliters for volume. And those are the two methods for finding volume of objects. Now to calculate density, now that you have that other information, let's take a look at just a quick example. So if you're given, it says calculate the density in grams per milliliter of aluminum if a 50 milliliter block weighs 135 grams. So we take the formula, which is mass divided by volume. So the mass is, in this case, 135 milliliters, or grams, I'm sorry, and the volume is 50 milliliters. So what you would do is divide the two, and you get a total of 2.70 grams per milliliter. So don't forget that we talked about significant figures. Because we're doing a division problem, the rule states that you will take the least amount of significant figures from the problem, and that's how many significant figures your answer would have. So between 135 grams and 50 milliliters, 50 milliliters has the least number of significant figures. It has 1. So that means that our answer would have to have 1 significant figure. So in our calculator, if it came out to 2.70, we'd have to round it with correct significant figures by rounding it to 3. So 3 grams per milliliter would be our answer with proper significant figures. In your ISN, right underneath your T-chart, you're going to go ahead and complete this density activity. You're going to find the density of this cube given here, and you're going to find the density of the rock given here. Use the information from the previous slide. Don't forget that this is one way of finding volume, and this is another way of finding the volume. Just in case you can't see it very well, it does read 30 milliliters for the starting volume, and then the ending volume on the next graduated cylinder is 40 milliliters. So just in case you can't see. As soon as you finish your assignment, go ahead and show it to me in class. And if you have any questions, you let me know.